This video is a demonstration of using HUTCH and associated open source tools to perform cohort discovery, servicing a query from the BC RQuest platform. HUTCH was developed as part of the TRIFIX project, TRE-FX. The HUTCH agent is an implementation of the TRIFIX executing agent, which lives in the workflow executor layer. It's responsible for providing a bidirectional RO-crate interface for executing workflows. You can see here how the HUTCH agent provides an API for interacting with the TRIFIX controller layer. When a job is submitted, it fetches a referenced RO-crate from an intermediary store and validates that the crate meets the TRIFIX 5-safes RO-crate profile and that the crate is in the appropriate state to trigger a workflow execution. Assuming the crate is valid, the HUTCH agent prepares to execute the job. It will fetch a workflow RO-crate from an air-gapped source and produce a configuration for HDR, the workflow execution service, to run that workflow. With the inputs provided in the 5-safes crate and the project's dataset connection details provided by the TRE controller. HDR is then started with the configuration and executes the workflow. It will pull any required container images from an air-gapped source, and then run the workflow steps against the dataset. HDR outputs a workflow run RO-crate describing the provenance of the workflow's execution. The HUTCH agent, upon receiving this output, places it in the intermediary store and initiates a request for egress. This is subject to the TRE's disclosure controls, as configured via the TRIFIX controller layer. If egress approval is granted, HUTCH incorporates the outputs into the 5-safes RO-crate and returns the updated output version to the intermediary store to be returned to the user. In this demonstration, we will follow the process I've just described for a cohort discovery query from BC RQuest. To facilitate the complete end-to-end journey, we will use the HUTCH controller, a lightweight implementation of the TRIFIX controller layer specifically built for this use case, and RQuest Bridge, which, as its name suggests, serves a bridge between the BC RQuest REST API and the 5-safes RO-crate and the HUTCH API. In this diagram, you can see that BC RQuest is effectively serving as a submission layer by which users can send jobs to the TRE. RQuest Bridge and the HUTCH controller together form the controller layer, where RQuest Bridge handles bidirectional, i.e. input and output, interactions with BC RQuest via outbound HTTP requests only, and the HUTCH controller does the same for the HUTCH agent. Everything in the workflow executor layer, here labeled HUTCH for simplicity, is as I described earlier. Note that while this supports running in an air-gapped environment across distributed infrastructure, for the purposes of this demo, we are running everything inside the TRE on a single virtual machine with internet access. For this demo, the HUTCH controller simply performs a pass-through automatic approval for disclosure control. At this point, I'd like to take the time to look briefly at the 5-safes RO-crate profile. In this demonstration, the RQuest Bridge generates that crate for the RQuest query it receives. And while we can inspect the input crate it generates as well as the output crate that HUTCH sends back, there isn't really time to explore it during the workflow execution. So let's take a look now. The 5-safes RO-crate profile specification can be found on the TRIFIX website. The RO-crate contains metadata surrounding checks performed in the process thus far, as well as information about the project and person who submitted the job. It also contains either a workflow directly or references a publicly available workflow, such as one available on Workflow Hub. Finally, it contains the inputs to that workflow for a given submission. And here we have a previously generated input crate for an RQuest query. If we look at the crate's metadata file, you can see its conformance to the RO-crate profile, including the 5-safes crate profile that we just discussed. It also references a workflow available publicly on Workflow Hub, and an input file for that workflow for this particular job. The metadata also contains mentions and details of any checks that have been passed in the process so far, as well as information on the project that this job was requested for and the organization and even individual who requested it. If we look at the input file referenced, you can see that it is an request availability query payload in its native form as raw JSON received from the request REST API. It contains the query information for patients matching a condition for a given OMOP code. Here on Workflow Hub, you can see the workflow we will be running. It executes an open source command line tool we developed called request OMOP Worker by pulling a container image for that tool and then executing it with the provided inputs. We will be using this instance of Minio as our intermediary store, and we'll revisit this bucket to see the files stored during the process. In production, you might use different buckets or path prefixes for different stages of the process, but for this demo, we'll pretty much just be putting everything into this bucket. Here we have our demo VM. Most of the stack in here is running in Docker, bootstrapped using Docker Compose. You can see Minio, the intermediary store, and RabbitMQ, which HUTCH uses to manage the jobs it's executing. We're also running the request bridge and the HUTCH controller. The HUTCH agent and Wifex do not run containerized at this time. The HUTCH agent is running on this machine as a systemd service. We're in Ubuntu. And Wifex is executed on demand by the HUTCH agent. The dataset is some synthetic OMOP data stored remotely in a Postgres database. Let's connect to our running services and tell their logs so we can see what happens when we send the request query. We'll do the request bridge at the top. The HUTCH controller in the middle, and the HUTCH agent at the bottom. You can see already that the request bridge is regularly polling request's API to see if there are any jobs waiting. The other two services are just listening for HTTP requests. Now that we're tailing logs for everything, we can submit a query. Here's the BC request interface. I'm going to create a new query, and I'm going to send it to two different collections. You can imagine that these are different data sets in different TREs, but in this case, however, they're both backed by the same data set. One is running BC Link, and the other is our HUTCH VM. For the query against this dataset, we'll just look for patients with a breathing-related condition, since I know this dataset will have some. So now that we've sent that query to both of our targets, we can look at the HUTCH environment. You can see there that the request bridge accepted a job, and if we look at HUTCH's logs, we can see that it too received a jobs request that it has accepted. It's extracted the crate it received and sent status reports to the TRE controller. The HUTCH controller has received those at its update status for TRE endpoint. Meanwhile, the HUTCH agent has downloaded a workflow and unpacked it, and then triggered Wifex, the workflow execution service, to run the workflow. In the meantime, the request bridge is back to polling the request API to see if there are any more jobs. The HUTCH controller is just listening for status updates. Now Wifex has just completed the job, and so HUTCH will unpack the outputs that it finds and send status updates to the TRE controller. It'll notify it of the intent to egress those outputs. And here we can see that the controller has fully approved them very quickly. HUTCH receives that approval confirmation and then sends a complete status report, at which point it will have uploaded the final output crate. If we look up at the RQuest logs just a little way up, we should find that it has found the final crate and downloaded it, unpacking the result to return to RQuest. And there it's completed handling that complete job. If we go back to the RQuest interface, you can see that both environments have completed the query and returned the same results, BC Link and HUTCH. If we return to our intermediary store, you can see what it was used for during the process. The first zip file here with the ID is the input RO crate generated by RQuest Bridge. The final result crate is the output RO crate, the last thing returned by HUTCH that contains the results. All the other files in here are what the HUTCH agent uploaded for egress inspection. They're outputs from the workflow execution, and they could be inspected by any necessary disclosure process, automated or manual or a combination of the two. Let's download the crates and have a quick look. So let's explore the zip files that we downloaded. I'm just going to extract this one so that we get the zip files inside. Here's our input crate with the ID. And you should see that this looks basically no different to the one we explored earlier. The query, however, should be for a different OMOP code. And you'll see the timestamps in the metadata should differ as well. If we look at the output crate, you can see it contains quite a bit more. It still has all the original information, including that same query file. And obviously it has a RO crate metadata file. But the metadata file has been expanded. So it now includes additional checks, for example, such as completing download of a workflow and disclosure approval. And it has outputs as well. If we look at the outputs, you can see this actually includes the entire workflow run RO crate from Wi-Fi with its own crate metadata. And you can see that we have the output from that run, which is a JSON response for RQuest. And there's our query count that we saw in the RQuest UI. I hope you've enjoyed this demo of cohort discovery using HUTCH. Everything demonstrated here, except BC RQuest, is an open source tool. Most of them are available on GitHub. This is the HUTCH repository, which includes the HUTCH agent and the HUTCH controller. The Wi-Fi workflow execution service repository is here. And this RQuest tools repository contains the RQuest Bridge application and also the code for the OMOP worker, which runs the query as triggered by the workflow. Finally, this page, available at this URL, contains links related to our work in federated analytics.